All right, how's it going, everyone? Today we are going to move one step further, and we're going to add in our transition metals from the writing and naming that we learned yesterday, which is the regular metals. So let's get going. All right, before we get into the transition metals, I want to go over really briefly just a review from what we learned yesterday um, for when we write and name these things. So when we're writing them, remember that the cation always goes first. Remember that the cation is the positive ion, it's the metal, so that one's always written first. The anion, which is the nonmetal, which is the negative ion, is always written last. When we have these things and we're using the ions, we put them together in their charge. Okay? Their overall charge has to be 0. So if you add them together and it doesn't equal 0, you're going to have to drop and swap the charges just to give you the right amount. All right, and then if you add them up that way, they should cancel out equaling 0. So very quickly, let's look at a couple of examples. The first one we have is aluminum and oxygen. You should know that aluminum's charge is +3, oxygen's charge is -2. Now if I just add these two things together, I would get a +1 charge, which doesn't give me 0. So I'm going to have to drop the charges and swap the numbers. When I do that, I end up with Al2O3. This tells us that we need 2 aluminums to cancel out 3 oxygens. Number 2, magnesium and fluorine. Magnesium's charge is +2 and fluorine's charge is -1. So again, if you add these two charges together as they are, you get +1, so it doesn't cancel out the 0. So drop and swap. Remember, when I drop the charges and I swap the numbers, I'm swapping down to the subscripts. So Mg has 1 and F has 2. So I need 2 Fs for every 1 Mg to have a neutral compound. The third example here, we have potassium and sulfur. Potassium's charge is +1 and sulfur's charge is -2. Again, if I were to add these together, I would come up with -1. So I have to drop and swap. When I drop and swap, I get K2S. Again, the whole thing with this is that you must have an overall charge of 0. Okay? Alright, so let's dive into the transition metals here. Starting on the left side here, it says writing and naming chemical compounds that have more than one charge. This involves the transition metals. Some metals have more than one charge. You must check the periodic table to see if the metal, the first ion in the charge, has more than one charge. On your periodic table, it's on the back. So this little cutout I have on the right, that comes from the little chart that's on the bottom right of the back side of your periodic table. So these charges are always given to you. The correct charge to use for that compound will be written as a Roman numeral in the given name. The Roman numeral is in parentheses and it refers to the charge of the metal ion. So your example might be like lead Roman numeral 2 oxide. That Roman numeral 2 represents the charge on the lead, so it's +2. If it was lead Roman numeral 3 oxide, it would be lead +3, Pb +3. The nonmetal, the second ion charge, comes from the periodic table, exactly how we learned yesterday. So all the nonmetals come from the front side of that periodic table, just as we learned. And then we're going to follow the same rules as we did before, like we did in class, and we're just going to try to come up with an overall compound that is equal to 0. So the best way to do this stuff is just a bunch of practice. The more you practice with this, the better off you're going to be. If you think you know what's going on, you might want to go ahead and just pause the video so that way you can go ahead and try to do all these examples on your own, and then let the video play and see if you got them. If you're having trouble with this stuff, stay with me for the first couple, then pause the video, and then try to do the ones on your own, okay? So the first one we have is tin 2 chloride. The Roman numeral 2 represents the charge on tin. So that's why it's Sn plus 2. Chloride is still chlorine with a charge of -1, so that charge doesn't change. So now we're just going to drop and swap, and I get SnCl2. Again, this tells us we need 2 chlorines for every 1 tin. In example number 2, we have lead, Roman numeral 4, oxide. So this tells us that the charge on lead is plus 4. The charge on oxygen, or oxide, is still minus 2. Again, if you add these two charges together, they're not 0. So we have to end up going and dropping and swapping. So I get Pb2O4. Now I'm not done here. Remember yesterday we talked about if you can reduce the subscripts by the same number, you should do so. So in this one, we have PbO2. Example 3, we have magnesium fluoride. Magnesium fluoride. Magnesium is not a transition metal. This comes from the front part of the periodic table, so we still know that magnesium's charge is plus 2 and fluorine's charge is minus 1. Again, drop and swap, and you should end up with MgF2. Example 4, we have cobalt, Roman numeral 3, bromide. So again, the Roman numeral 3 represents the charge on cobalt, so it's plus 3. So we have cobalt plus 3 and bromine, which is a minus 1 charge. Again, go ahead and drop and swap the charges. When you drop and swap the charges, you have COBr3. In example number 5, we have iodine and iron, specifically iron 2, because it's in Roman numerals. Now when we write this, remember, we're always writing the metal first, which is Fe plus 2, and then the anion, which is iodine, minus 1. Again, drop and swap your charges, so we have FeI2. Number 6, we have nitrogen and zinc. Now with zinc, zinc is a transition metal, but if you look on the back of that periodic table, you'll notice that zinc only has 1 charge. So zinc has 1 charge, which tells you it's plus 2. Nitrogen's charge is still minus 3. Again, the metal is always written first, so drop and swap. When you do that, you should get Zn3N2. Again, remember that we need 3 zincs to cancel out the 2 nitrogens. In example number 7 here, we have silver chloride. Silver also has only got 1 charge. If you look on that periodic table at the bottom, you see it's Ag that's over there on the right side. It only is plus 1. So notice in the way I wrote it, I didn't put the Roman numeral. Now if you put silver in parentheses Roman numeral 1, that's fine. But because it only has 1 charge, I don't need to necessarily write the Roman numeral. Chloride, which is minus 1. So we have Ag plus 1 and Cl minus 1. If you add the charges together, they actually equal out. So we just have AgCl. Again, when you're looking at this stuff, the important thing is to look for those Roman numerals when the thing is actually written out, when the formula is actually written out and you're just writing, or when the name is written out and you're just writing the formula. All right, so in this part, we're going to look at some naming. So this is just going in reverse in a sense. If you're still feeling good about this stuff, I would go ahead and pause the video. Try to do this on your own, so that way you guys can go back and check when you're done. Again, if you're still confused, stick with me. Walk through every example, and then you can practice later. So the first example we have is NaCl. We know that Na is sodium. We know that Cl is chlorine. So we put them together. We have NaCl, which is sodium chloride. For example number 2, we have Mg and Br. Mg is magnesium. We know that's not a transition metal. So we just have magnesium bromide. Number 3, we have AgF. Now we come to Ag, which is silver, and we know that silver is a transition metal. It's one of our D block elements. So with this one, we got to just double check just to see if it has more than 1 charge. Now if you look on the back of the periodic table, like we saw in the example before, that silver only has a plus 1 charge. So when I write this one, I can just simply put silver fluoride. If you put silver 1 fluoride, that is 100% fine. You can get in the habit of always putting a Roman numeral with your transition metals, just as a habit. All right, number 4. In number 4, we have AuCl3. Now Au is gold, so we have a transition metal. Now if we look on the back of that periodic table, you'll notice that AU can be +1 or +3. Now, how do I know? So what you have to think about here is you've got to look at your anion. Your anion in this case is chlorine. It has a 3 after it. That means I've used 3 chlorines. All right, remember chlorine's charge is -1. So currently on just chlorine, I have a -3 charge. So looking at our transition metals, we've got to cancel out the 3 chlorines by using 1 charge for gold. So it has to be +3. So we write gold, Roman numeral 3, chloride. Again, why am I using 3 for gold? If gold's charge is +3 and I have 3 chlorines at -1, +3 cancels out the negative from chlorine. Number 5, we have PbO. Now, again, if you look at this, you see that Pb is a transition metal. Most of the time it's either going to be +2 or +4. Now, here's the problem. How do we know? Again, look at your anion. If you look at oxygen, we know that the charge on oxygen is always -2. Well, if it was -2, there should be a Pb2 right there, but we don't see one. That tells us, or should tell you, that our charge is reduced down. So for this one, we should have lead 2 oxide. Okay? Now you can always go back and double check yourself and start from the beginning, just like if we were doing it, writing the formula. So you could start off by putting Pb +2 plus O -2 and then drop and swap and see what happens. You can do the same thing for lead +4 and O2 and see what happens. Okay? And our last example, just kind of a giveaway from what we just saw, we have PbO2. Now again, we know that oxygen's charge is -2. So if I gave Pb a +2, I would have the same one I had before, but I have a 2 on that oxygen, so that should tell you that we're lead 4 oxide. Again, go back and double check. Take lead +4 plus O -2, drop and swap and see what you come up with. All right, that's it for transition metals for today. The big thing is understanding when to use those Roman numerals. Remember, the Roman numerals designate the charge on the positive or metal ion.